class again. As you know that in the previous class I have completely studied about limits, and we also discussed a lot of problems based on limits. In this class I will discuss one of the important topic of calculus, which is known as differentiability. In this class mainly I will discuss fundamentally about differentiability. Means that I want to tell you what is differentiability, what is the geometrical interpretation of differentiability, how do we use how can we solve problems which is relevant to differentiability, and what is the application of differentiability, as well as what is the importance of differentiability in physics. And we also discuss physically significance of differentiability. But that may say completely, you can say that here we will discuss mainly in this video what is differentiability. What is differentiability? Firstly, before starting, I want to again remember you what is the meaning of limits. As I have told in a previous video what is limits, and I have also discussed many problems. But differentiability is completely relevant to limits. If you couldn't understand limits problem or what is the actual meaning of limits, then it becomes very difficult for you, or you cannot understand differentiability. Because differentiability is first time when you are starting to solve problems, then you discuss solving problem with the help of a first principle or a Ab-Initio method. In that case, we always use limits. If you don't know limits, then you can't solve any problems which is relevant to differentiability. So I always suggest, if you want to learn this chapter, before this chapter you learn very well trigonometry and limits. Something you have also, I think you should also knowledge of functions, but there is no more importance at basic levels or college levels. So I want to tell you, at least you learn very well trigonometry and limits. After it, differentiability becomes very easy for you. Before starting, I want to give you some base. Firstly, I want to prerequirements. What is the basics of differentiability? Basics of differentiability means that for learning differentiability, what is supporting element? Supporting element means that if you want to learn very well differentiability, then firstly you learn about very well function. Thereafter, I think under function trigonometry also comes, because trigonometric function is a kind of function. So I don't write especially, that means individually, about trigonometric topic, and second will be limits. These two topics are very important to learn differentiability. So I will always suggest to learn first the function, thereafter limits. Then you can easily understand differentiability. Because while you are starting to solve problems which is based on differentiability, then standard problem always take in types of function. If you have no idea about function, types of function, you cannot solve easily. You solve some problems which is just a basics, but standard level problem you cannot solve. So I always suggest you try to learn firstly function, thereafter limits, then you can easily learn differentiability. Now supporting elements, I take after supporting element, what is slope? Because if you have no idea about slope, then you couldn't understand some important point about differentiability. So I want to give you some supporting element to understand differentiability. What is the actual meaning of slope? I think if you know, or if you have studied about coordinate geometry, then you definitely know. You will definitely know about slope. What is the meaning of slope? Actually, it is nothing. It is a very simple definition terms. But further, I want to explain it. What is slope? It is defined as tangent of that angle. Tangent means tan theta. As you know that tan theta, tan is a short form of tangent. Tan is a short form of a tangent. Full name is a tangent. It is defined as a tangent of that angle. It is defined as a tangent of that angle which is made by a straight line with respect to positive x-axis. It is the actual meaning of slope. Suppose that this is a coordinate axis system in two variables, that means in 2D. We take x-axis and y-axis, and there is a line which is passing through point A and B, Suppose that the coordinate of A is x1 y1 and coordinate of B is x2 y2. If you do not like take here, you can take anywhere. Don't worry. Suppose that A is equal to coordinate of A will be x1 y1 and coordinate of B x2 y2. And anyone asks to you what is the slope of AB? How can you say about slope of this straight line, that means line L? You can take it. Firstly, if you go through definition, it is defined as tangent of that angle which is made by a straight line with respect to positive x-axis. Means that this is the line. How much angle this line makes with respect to positive x-axis? Can you determine? Suppose that this angle is a theta. Then slope of line L, you can take AB. Line L will be tan theta, because I have already defined slope means that a tangent of that angle which is made by line, that means which is made by a straight line with respect to positive x-axis. This angle measured with respect to positive x-axis. Don't take by this way. It is always measured with respect to positive x-axis. This is the concept of slope. Suppose that this line makes angle 45 degree. Suppose that this line makes angle 45 degree with positive x-axis. What will happen here? In that case, slope of AB will be tan 45, which will be 1. This is the slope of line L or line AB. Now, I want to generalize here. Suppose that there is no given angle by which angle this line what is the measure of angle by which this line inclined with respect to positive x-axis? In that case, suppose that there is given L is a line which passes through A and B having coordinates x1 y1 and x2 y2. In that case, how can you determine the slope of line L or slope of line AB? Can you express slope of line AB or L in terms of x1 y1 x2 y2? Yeah, it is very easy. Firstly, you draw perpendicular from B to x-axis, and similarly draw perpendicular from A to x-axis. As you know that this is x1. See here carefully. Here, this is coordinate of A will be x1 y1. Means that x1 is the perpendicular distance. What is the x1 y1? X1 is abscissa, y1 is the ordinate. What is x1? x1, that means abscissa, which is defined as the perpendicular distance from y-axis to that point. That means definitely you can say that x1 is nothing just like this distance, and this distance is x2. Have you understood? Now, similarly, this perpendicular distance, as you know that ordinate is defined as perpendicular distance from x-axis to that point. So, this perpendicular length will be y2 and this perpendicular length will be y1. Have you understood? In that case, again draw perpendicular from A to, suppose that this point will be P and this point will be Q. And draw perpendicular from A to BQ, from A to BQ, A to BQ at M. In that case, this angle will be 90 degree. And as you know that AM is parallel to x-axis. In that case, if this angle will be theta, then this angle also theta by corresponding angle. And as you know that this length from O to Q will be x2 and O to P will be x1. So can you tell me about PQ? What is the length of PQ? x2 minus x1. If PQ is equal to x2 minus x1, then you can definitely tell about AM. AM is also equal to PQ. So AM is equal to also what? x2 minus x1. Why? Because PQMA is a rectangle. How can you tell about it? It is a rectangle. Because this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. If each a quadrilateral having each angle 90 degree, then in that case it becomes rectangle. So PQ is equal to AM, and as you know that PQ is equal to x2 minus x1, so AM will be also x2 minus x1. Now I want to take again length of BM. What can you say about BM? As you know that totally AP is equal to what? Y1 and BQ is equal to what? Y2. So if AP is equal to Y1 and BQ is equal to Y2, then BM is equal to what? Y2 minus Y1. Because if AP is equal to Y1, then MQ is equal to also Y1. If MQ is equal to Y1, and as you know that BQ is equal to Y2, if this will be Y1 and whole length will be Y2, then it becomes definitely Y2 minus Y1. So what can you say here? BM is equal to Y2 minus Y1. So I want to write here BM is equal to Y2 minus Y1. Is it visual? Now see here in triangle A and B. Right here in right angle triangle A and B, this tan theta will be BM by AM. Can you tell? BM by AM, because tangent is nothing in terms of tan theta. So tan theta is equal to BM by AM. Now if you want to express this length BM and AM in terms of abscissa and ordinate, what can you say about BM? BM is equal to Y2 minus Y1 divided by AM. What is AM? Here AM is equal to x2 minus x1. So if you know the length of, that means abscissa, and suppose that if you know there is a line which passes through 2 points whose coordinates are known, then in that case you can find that slope of that straight line as a difference of ratio of difference of ordinate divided by difference of abscissa. This is the definition of slope. So I think you understand very well slope. How can you determine the slope of a straight line? If you understand, then I want to go towards main point of this chapter. Right here, what is the actual meaning of slope? Now, my main point is derivative. we have to study differentiability. To find differentiability, sometimes derivative it is also known as to find derivative of a function fx at x is equal to a. We have to find derivative. Sometimes derivative is also written as derivable. Don't worry about it. To find the derivative of a function fx at x is equal to a. Firstly, suppose that we take here there is a function fx. This is y is equal to fx. There is a point A. Suppose that this is a point A at which its functional value will be fa. At which its functional value will be fa, because if fx is a function and if you want to find the value of function fx at x is equal to a, simply you have to put in or you can replace x by a. That means suppose that this is the point A whose abscissa a and coordinate, that means ordinate will be fa. Now you have to find the derivative of a function fx at x is equal to a. You have to find its derivative. How can you find derivative of a function? Suppose that there is a point, there are 2 points which is very close to a. Very close to a. There is another point P and there is second point Q. As I have told you, P and Q are very close to A. P and Q are very close to A. In that case, what can you say? In that case, can you tell about it? It will be A minus H and it will be A plus H. Its functional value will be at P will be A minus H, Fa minus H, and its functional value will be A plus H and Fa plus H. Because I have already told you P and Q are very close to A. Very close to A. And if P and Q are very close to A, in that case, abscissa differ only by a infinitesimal, that means H is a very small positive quantity. In that case, A will differ only a very small quantity. So I have taken here A minus H and A plus H, ordinate abscissa of P and Q respectively, and in that case you get definitely ordinate of P will be Fa minus H and ordinate of Q will be Fa plus H. Now again I want to tell you, why do we take 2 points near to A? What is the reason behind it? There is simple logic. Suppose that I want to again take its use. Suppose that there is a path of any object. This is a path of any object. Suppose that there is a particles which moves on this path. This path. It is very clear that you cannot find velocity of a object. Suppose that I have asked to you, you have to find the velocity of object at this point A. How can you find? Again, I have said to you, you have to find the velocity of object at this point. How can you find? Is it does there any algebraic method, as you know that velocity is equal to perpendicular, that means velocity is equal to distance divided by time, or you can say that displacement divided by time. Is there any formula similar by which you can find the velocity of an object or a velocity of a particle at this point A and B? No, because I have asked to you at particular time. Suppose that any objects which travels before he travels already 5 minutes, and I have just asked you have to find the velocity of the object at 5 minutes 1 second. Can you find? No, you cannot determine by a simple algebra. So definitely you have to go or you need a different kind of mathematics, which will be this will be discussed in differentiability. I think you know you definitely learn in physics instantaneous velocity of a object or particle. Instantaneous velocity means that you have to find the velocity of a particle or object at particular time. Now, here A is a point and P and Q are very close to A, and you have to find, suppose that here you have to find the velocity of a particle at the point A. How can you find? Definitely you will go neighborhood of A. And you see what is the you will go neighborhood of A, and you will see what is the velocity of particles at neighborhood of P and Q. So I have taken here two neighborhood point of A. Again, rub this part. Here A is a point and P and Q are two neighborhood points of A. Now I want to find the slope of, as you know that mainly you have to find the slope of this part. You have to find the slope of fx at x is equal to A. At particular point at x is equal to A. You have to find the slope of because I want to again tell you. Actually, differentiability or derivable, it is used to find slope of a function at particular point. So I want to tell you, firstly you learn, you have to find or you have to take your goal. What is your goal? There is simple goal, you have to find the slope of a function fx at x equal to A. So, I want to find slope of fx at x equal to A. For which, I have taken two neighborhood points of A, P and Q having coordinates A minus h, f minus h, and A plus h, f plus h. Now, I want to find the slope of this chord AB. This chord AB, because P and Q are two different points. In that case, definitely, if you want to find the slope of line segment PQ, then you definitely try to find slope of PQ. You can find, because I have already told you, if a line L or if a line AB which passing through x1 y1 and x2 y2, then its slope will be y2 minus y1 divided by x2 minus x1. So, can you tell me here, slope of PQ is equal to y1. Suppose that it is x1 y1 and it is x2 y2. What can you tell me here? Slope of PQ will be y2. Y2 is equal to fa plus h. Fa plus h. And don't take here P. Sorry. You have to find the this point P. Don't worry. You have to find the slope of AQ, because AQ is also a chord. In that case, slope of PQ AQ is equal to y2 means that fa plus h minus this point is what? AFA. This is x1 y1. Don't take here. This is x1 y1. In that case, you will tell me slope of AQ is equal to fa plus h minus fa divided by x2, that means a plus h minus a x1 a. In that case, it will be fa plus h minus fa divided by h. This is the slope of AQ. Slope of AQ. Again, I want to find the slope of PAP. What? AP. So can you tell me here, slope of AP will be y2 minus y1. You can take, suppose that this is x1 for 1 second, suppose that this is x2, this will be y2. In that case, can you tell me y2 minus y1, that means fa, divided by x2 a minus h minus a. Have you understood? If you cancel this term a, what do you get? You get fa minus h minus fa divided by minus h. Now, I want to tell you, suppose that, as you know that you have to find the slope of what? fx, y is equal to fx. What is your goal? You have to find the slope of y is equal to fx at x is equal to a, where a is this point. And you have to find the slope of this, that means this function at x is equal to a. Definitely, you will take a tangent. You will take a tangent at this point, and you will tell me how much angle this line makes with respect to positive x-axis. You will definitely ask to me how much angle this line which passes through this point A, that means just touches this line, this curve y equal to fx, then how much angle makes with respect to positive x-axis? Because if you don't know this angle, then you couldn't determine the tangent of this fx at x is equal to a. So I want to draw firstly tangent at x is equal to a. In that case, how can you determine? As you know that slope of this tangent will be, suppose that this line will be L. Then slope of line L will be tan theta, because it makes angle with respect to positive x-axis will be theta. So now I have to find simply slope of this line L. As you know that A is a point and P and Q are very very close to A. Very very close to A. For well understanding, I have taken P and Q by some margin with respect to A. Or not, P and Q are very very close to A. That means you can think a small distance between A and P, A and Q. That means, now I want to tell you, suppose that another way, I want to take P very close to A. Suppose that for 1 second I have taken here P. In that case, code will be this. Again, I have taken P here. In that case, this code will be this. Similarly, I want to approach this point P very very close to A, and from this side Q will be also approached near to A, very very closely to A. In that case, what can you tell me? I want to simply tell you, don't coincide P and Q to A. Don't coincide P and Q at A. Otherwise, you can take very very close to A. Otherwise, you can take very very close to A. Simply, I want to suppose that this is A, and I want to take P here very very close to A, and similarly Q is also very very close to P. Sorry, Q is also very very close to A. In that case, what can you tell me? In that case, A and Q are very close to Q. So if you draw the chord AQ and AP separately, then it is nothing. It becomes a straight line, and you can treat this straight line nothing. This is a tangent because P and Q are very close to it. And if you wish, draw the tangent passing through A, and you know that P and Q are very close to A. Definitely it also passes through P and Q. What can you say in that case? In that case, you can tell me slope of AQ is equal to slope of AP. Slope of AQ is equal to slope of AP. So I want to tell you, so tangent of L is equal to tan theta, which will be FA plus H minus FA by H is equal to FA minus H minus FA by minus H. Here H and minus H is very close to 0, and it is very small positive quantity. In that case, you definitely use limits, because I have already told you, because H is a very positive quantity. If you take 0, in that case it becomes not defined. That means it does not define. In that case, definitely it gives indeterminate form. So I want to tell you, take here limits. Can you take here limits? Limit h tends to 0. Similarly, it will be else to limit h tends to 0. This is nothing. This is the derivative of fx at x is equal to a. This is nothing. This is derivative of fx at x is equal to a. This part is known as right hand derivative of fx at x is equal to a, while this is known as left hand derivative of fx at x is equal to a. Sometimes it is also denoted by LHD of fx, LHD, that means left hand derivative, and this is denoted by RHD, that means RHD, that means right hand derivative of fx at x equal to a, while it is denoted by LHD, that means it shows left hand derivative of fx at x equal to a. Now, and there are also many notations to represent both limits. Now I want to explain again separately. Firstly, write it very well. I think you understand what is the actual meaning of differentiability. Differentiability is nothing, or derivative of a function is nothing, just like a slope of a function at a particular point. So I want to tell you here, again draw the graph y is equal to fx, and this is point A, fa. There are 2 points P and Q, which is very close to A plus H, fa plus H, and this point will be P, which is whose coordinate will be A minus H, fa minus H. Now A, fa, and I have taken here length line L. Then I have told you, or we obtained slope of L is equal to what? Limits h tends to 0, fa plus h minus fa divided by h is equal to limits h tends to 0, fa minus h minus fa divided by minus h. Now I want to tell you, there are 2 expressions to obtain slope of L. Definitely, as you know that slope of a line or slope of a function at particular point is unique. There does not exist two slope. That means there does not exist two different value of a slope at a particular point. Because suppose that this line makes for 45 degree angle, in that case tan 45 is a unique value. So both expression is different. but their value should be same, then you can tell me slope of L exists uniquely. Because if it is not unique, in that case you cannot tell me slope of L is equal to this or that. So slope of L exists if limits h tends to fa plus h minus fa divided by h is equal to limits h tends to 0. You can take here right hand side and left hand side according to limits. Left hand side will be limits fa minus h minus fa divided by minus h. Sometimes it is also, this is also denoted by f0 plus f dash 0 plus, sorry. This is also denoted by f dash 0 plus. That means right hand derivative of fx at 0. And this is nothing. Sorry, take here a. I have taken 0. Right hand derivative of fx at x is equal to a. And this is nothing. Left hand derivative of fx at x is equal to a. Now you can tell me slope of L exists if both value will be same. Now I want to write, this is nothing, this is geometrical interpretation. I have explained it with the help of geometrical interpretation. Otherwise this is, you can take formula, sometimes you can, most of the teachers directly write its formula and you can solve easily. There is nothing, but I want to give you some concepts behind it. This is left hand derivative, this is right hand derivative, and this is left hand derivative. You can take right here. Here f dash a plus is equal right hand derivative of fx at x is equal to a. And this is what? This is what? You can write here f dash a minus is left hand. I want to write in short LHD, left hand derivative of fx at x equal to a. I think you understand very well. This is the actual concept of differentiability of a function fx is equal to a. Now I want to write it in other forms. In other form means that you can tell me derivative of fx at x is equal to a exists if limits, that means you can write here right hand, I want to write directly right hand derivative of fx at x is equal to a is same as left hand derivative of fx at x is equal to a. Now I want to write the right hand derivative. What is the expression of right hand derivative? That implies that right hand derivative will be limits h tends to 0 from right hand side fa plus h minus fa divided by h, and left hand derivative of fx at x is equal to a will be limits h tends to 0 fa minus h minus fa divided by minus h. This is the expression of it is. Now I want to rub this part. As existence of limit, whatever in any questions they ask to you, you have to find the derivative of fx at x is equal to a, then you can take LHD of fx is equal to a or RHD of fx at x equal to a, because you know that derivative of fx at x equal to exists, because he just tell you have to find the derivative of fx at x equal to a. So you can directly take RHD of fx at x equal to a or LHD of fx is equal to a. But I suggest you always try to take RHD, because minus always gives you some problem. So I always suggest you take RHD, because in RHD there is no minus. Simply here there is minus, but at denominator you always carry negative sign. It becomes something different. So I don't suggest you take RHD. But while they tell you there is a function and some constant in left hand side or RHD in that means there is taken two different arbitrary constant, and it says to you derivative of a function exists. You have to find the value of that constant. In that case you have to find RHD as well as RHD, and you equate them. Then you can easily find derivative of a function. Sorry, you can find the value of arbitrary constant. This is the simple way. Now I want to write notation. What is the notation of this? Before writing it, I want to write this method of finding derivative of a function is also known as first principle method or first principle method or Ab-Initio. This is Greek word, that means Greek word which is nothing, just like by starting concept, beginning methods. That means or Ab-Initio method. This method of finding derivative of a function known as first principle method or Ab-Initio method. It is denoted by, there are many notations. It is denoted by, suppose that for 1 second, suppose that there is a fx is a function. Suppose that it is y. Y is what? Function. What is what? It is y. Y is equal to fx. In that case, it is denoted by y dash. Y dash. It is written as y dash. That means this is completely denoted by y dash. If you find anyone, if suggest you have to find the value of y dash, then you can find anyway. LHD or LHD. It is also denoted by or f dash x. It is also denoted by f dash x. F dash x means that LHD or LHD anyway. It is also denoted by y1. It is also denoted by y1. If there is written y1, it's meaning that whatever they use y1, they always mention y1 represents first derivative of a fx. And it is also denoted by dy dx. It is also denoted by dy dx or dfx dx. These are some notations to determine the derivative of fx. But some famous is this notation and this. In higher classes, sometimes they use y1, y dash, dfx, dx. But most famous is dy dx, f dash x. Have you understood? So remember that whatever in problem they told you, you have to find the derivative of function fx at x equal to a. Then you can use f dash x or dy dx. Be careful, sometimes the students read this symbol dy by dx. This is wrong way to read it. This is read as dy, simply read dy y by no dy dx. dy dx. You can write there read as d dy dx. Don't read the ratio because it is not a ratio. It is a simply notation. It is not a, in other classes it is also known as an operator, but I don't use here. It is nothing. It is a simple notation. So don't read as dy by dx. It is wrong way to read it. Sometimes most of the teachers or as well as the students read it dy by dx. This is not a good way to read it. So I suggest you read it dy dx. There are also methods to read it. Dy dx, it is also read as you know that y is equal to fx. I have already told you. Read as differential coefficient of y or fx with respect to x. But nobody read it. Such a long statement, differential coefficient of fx with respect to x. He simply read dy dx. But all these are very easy. Y dash, f dash x, y1. It is also a differential coefficient of fx with respect to x. Now, if you understand it, then I want to suggest you what is the next topic for you again. For 1 minute, I want to say. There is nothing. Now I want to tell you two important terms. First will be increment of a function. I think you understand very well what is the actual meaning of derivative of a function and what is geometrical interpretation. I have explained. And what does it represent? Sometimes you need in your examination it asks to you have to find the derivative of a function at a particular point, or sometimes it will tell you have to find the slope of a function at particular point. So be careful while they ask to you about its slope or derivative of function, always represents its derivative. Now I want to take increment of a function. Sometimes a student confuse with this term, increment. Increment word represents not increasing. Suppose that 2 is a number, and I will tell you have to take increment of 2. Then you can take 2.001, 2.01, 2.00001, and you can take also 1.999, 1.99, 1.98. Because why increment is used? What is used for any term or any function? In that case, you can take neighborhood of that function. That means that value which is very very close to 2. This is used increment. So be careful here. Increment means that maybe decreasing, maybe increasing. Don't behave as a increment means that we take greater than 2 or only less than 2. Always take maybe less than or greater than 2. Now I want to suggest you, because increment is very very important for here. You see here fx is a function, y is equal to fx, and you have to find the slope of y is equal to fx or tangent of fx. In that case, you take two neighboring points, and if you see that point, then we take neighborhood. That means a at a minus h at a plus a. What is it? You decrease the value of a in case of a minus h, and you increase the value of f at a, that means by a plus h. This is the, if you take in aggregate form whole expression, then you can take here I have increment. I have taken here increment of x. That means I want to again write increment of fx. Let y be a function of x. The value of y will change with respect to x. The value of y will change with respect to x. Why? Because function of x means that, this is the very simple term. Function means that that means value of y be a function of x. It is a standard mathematical statement. You can tell also another mathematical statement in place of it. Y will change with respect to x. Or you can also tell me y will change or y changes according as x. This is the actual meaning of function. There are many ways by which understand value means that actual concept of function. You will learn with the help of set theory and relation, and there are also other methods to learn function. I want to hint you in very small hint. Suppose that y is equal to x square plus 1. Y is equal to x square plus 1. And I will don't take y is equal to x square plus 1. I have taken y is equal to x plus 1. And I have told you, you have to draw the graph of y is equal to x plus 1. What do you do? What will you do? In that case, you definitely you have already learned in class 10th, 9th. I have taken x, y, and after putting the some value of x, we get value of y. But it is not necessary always put a value of x and we get a value of y. Why do we put always x? It becomes tradition, but it is not a good way. You can put a value of y and you can also get a value of x. In that case, you will definitely arrive. There will be a rule or there will be another concept by which we put value of x and we get value of y. Variables are classified in two parts: dependent variable and independent variable. Dependent and independent. Dependent means that if any variable, if value of any variable depends upon another variable, in that case that will be independent variable. And that variable on which independent value of independent variable depends is called dependent variable. So independent variable. Here, suppose that sometimes mostly students think we put value of x and we get value of y. In that case, definitely y depends upon x. But it is not necessary. You can write here x is a dependent variable, x is a dependent variable, y is a independent variable. In that case, you put value of y and you get value of x. But before it, you have to mention it. But don't worry, you can take anywhere for your classes level. Now, I want to tell you again, here y behaves as a dependent variable and x behaves as an independent variable. As you know that if we treat y as a dependent variable, x is an independent variable, then you put then value of y changes according as x. That means if you maybe increase or decrement, there is no matter, but you will definitely tell me if value of x changed by any value, then my value of y also changes. So value of y changes accordingly as x. It's combine. It's that means it is simply expressed as y is a function of x. So y is a function of x. It is also can be expressed as y changes according as x, y depends upon x. All these are equal or equivalent. Now I want to write let y be a function of x. The value of y will change with respect to x because I have already explained this actual meaning of a function. Now x. Suppose that x is changed by del x, that is x plus del x. This is del, this is del, del, this is delta, this is nebula. That means converse of triangle, converse of delta is nebula. This is delta. Suppose that x is changed by del x. In which case we use del. There is a while you change a value of any variable by a small quantity, then you can use del. I think you can also use h, but I want to write del x because it is it becomes very standard. Suppose that x is changed by del x, that is x plus del x. Then I want to tell you the meaning of plus. The meaning of plus. Don't worry because del x may be positive and negative. I have written here only changed means that it doesn't show x is increased. I have also used here plus because I have done, but I have not mentioned about del x positive or negative because del x may be minus, suppose that it becomes minus 0.1, it may be 0.1. So I will suggest you, suppose that x is changed by del x, in that case it becomes x plus del x. It doesn't show I have increased x by del x. It may be decreased by del x because if del x is positive, it may increase, but if del x is negative, in that case it becomes it decreases. So I have used an increment. So I want to suggest you, suppose that x is changed by del x, that is x plus del x, then y changes also y, or you can write also y fx changes y plus del y or fx plus del x. Y plus del y or fx plus del x. Have you understood? That means in first case we get y is equal to fx, and in second case I have written here if x is changed by del x, then value of fx plus del x also changed by del y. Here it is equation second. Now I want to take difference of equation second and equation first. In that case, you can write here equation second minus equation first will be y plus del y minus y is equal to fx plus del x minus fx. Can you write here? So del y is equal to fx plus del x minus fx. This is equation third. Now I want to take ratio of equation third and equation third and y plus del y. This is del y and now I want to take here del I have take get here del y is equal to fx plus del x minus fx, which will be equation 3. Now I want to rub above part. Now, what is del y? What is del y? You can tell del y is increment of fx. I have not used here increases. I have used here increment. May be positive or negative. It may decrease the value of fx. It may increase the value of fx. So you can write here del y is increment of fx, which is equal to fx plus del x minus fx, which is supposed as equation 3. After dividing on both sides by del x, what do you get? It is del x. As you know that del x is a very positive, very small positive quantity. So, as you know that h is a very small positive quantity. As del x tends to 0, means that del x is a very positive quantity, very small positive quantity, or in other words you can tell me when del x approaches to 0. I am not, I want to tell you del x is a very small positive quantity. Now, when del x approaches to 0, in other words you can tell as well. Now, in that case, definitely, if you take here del x is equal to 0, it gives indeterminate form. Definitely, you will use here limits. So, can you write here limits del x tends to 0, del y by del x is equal to fx plus del x minus fx divided by del x, and I have to also use here the limits del x tends to 0. This is the limits del y by del x, limit del x tends to 0, fx plus del x minus fx by del x. As you know that you will definitely confuse here. Sir, you will take here only minus, but here we do not get, that means it is just as RHD, right hand derivative, but do not use here LHD. This is also LHD. If del x is a negative, if del x is a negative, in that case you get here negative, and here you will get also negative. So it is also LHD, RHD simultaneously. Don't worry here. Now, see here, del y by del x. This is what? This is what? This is nothing. Ratio of increment of fx by del x with respect to increment of x. Increment of x. That means ratio of increment of y and increment of x. Or you can tell also ratio of increment of x, fx and x, because y is a function of y is equal to fx. So you can tell it. Now I want to write again here in explained form. In explained form, del y del x is a rate measure. I don't write it as it is. I want to write directly. The limits del x tends to 0, del y del x is equal to limits del x tends to 0, fx plus del x minus fx divided by del x is limits del x tends to 0 del y by del x equal to limits del x tends to 0 fx plus del x minus fx by del x is nothing. It is just as suppose that here y as dependent variable, x as independent variable. So I want to write is nothing, it is just as ratio of increment of dependent variable and dependent variable, you can write in bracket y and independent variable x. I think you understand very well what is the actual meaning of del y del x and what is the geometrical interpretation as well as what is the physical interpretation. It is the physical significance of derivative. You can also write here it is rate measure fx of fx. It is a rate measure of fx fx or dependent variable. Per unit change in x or independent variable. It is a rate measure of fx or dependent variable per unit change in x or independent variable. This is the totally concept. This is total concept of differentiability. I will suggest you, it is not used to during solving problems, but I always suggest you, I always take all those concepts which lie behind any topics, either calculus or algebra or matrices and determinant. So I will suggest you learn it. If you wish to try, try to understand the concept of mathematics, then I will always with you. So right here and learn it very well. Now I want to again suggest you final point about the whole, that means summary of whole chapter. Summary of whole this video for 2 minutes. If y is equal to fx is a function, then derivative of fx at x equal to a is denoted by, you can write denoted by, don't write firstly denoted, derivative of fx at x equal to a exists if RHD, means that you write firstly in detail, right hand derivative of fx at x is equal to a is same as LHD, that means left hand derivative of fx at x equal to a. If y equal to fx is a function, then derivative of fx at x equal to a exists if RHS of RHD of fx at equal to a is equal to RHD of fx at x equal to a. If in any problem they ask to you, you have to check out existence of a derivative of a function at x equal to a, then you have to utilize this. If LSD and RSD both will be same, then you can tell about this about a given problem derivative of a function exists. That means RSD means that limits x tends to 0 fx plus h minus fx by h, it is also equal to limits h tends to 0 from left hand side, right, plus f x minus h minus fx divided by minus h. It is also denoted by simply f dash a plus h, and it is also denoted by f dash a minus, and totally it is denoted by dfx dx, or don't write here. This is the actual. If in any problem they ask to about existence of derivative of a function, then check find right hand derivative and left hand derivative. If both will be same, then you can tell derivative of a function exists. Have you understood? Now I want to again write another point about it. Suppose that in any question they give to you a function of fx is equal to, suppose that x square, and they told you have to find the f dash 2. Suppose that I want to tell you fx is equal to x square, and you have to find f dash 2. How can you find? It is very easy. I will discuss about in next class, but I suggest you, if fx is equal to x square and you have to find the f dash 2, then don't find the left hand derivative and the right hand derivative simultaneously. That means separately, because you know that derivative of fx is equal to x square exists, because they asked you have to find the f dash 2. If there exists definitely, because there exists f dash existing derivative of fx, so they asked you. So don't find LSD and RSD differently. So I will suggest you only find either LSD or RSD. But by my side, I will tell you find RSD, because it becomes very easy for you. Now, have you understood? Now I want to again write if y is equal to fx is a function, then derivative of fx is equal to a exists if at x equal to a is denoted by dy dx or f dash x or y dash. I have already written about it, but I want to. It's an important only point. So remember. Have you understood? Thanks all of you. I think you understand a whole video. In next class, I will again discuss some different concept. I think the concept is over. Only discussion of problems, different kind of problem. By which method? First principle method, or it is also known as Ab-Initio method. Actually time is over. 1 hour 13 minutes has been occurred. So in next class I will again discuss. Thanks a lot. Bye.